Alright, section 13, protective devices, low oil pressure shutdown, differential water and crankcase pressure detector, description, maintenance, overspeed, trip, description, maintenance, adjusting spring tension, hot oil shutdown, service data, specifications, and equipment list. Alright, the Electric Motor Division, GM, engine maintenance manual, section 13, protective devices. This section contains description, maintenance, with the information engine protective device for these devices are designed to shut down the engine within the event of a malfunction or occur during the engine operation. Low oil pressure, description of the low oil pressure shutdown plunger, figure 12, figure 13.1 is part of the low oil pressure shutdown device which is contained in the governor. Although the protective device is not an accessory to the engine, refer to section 12 of the description maintenance for the low oil pressure shutdown device. Figure 13 shows the low oil pressure shutdown plunger on the governor. Differential water crankcase pressure is detector and assembly. Description: combination differential water crankcase pressure detector with figure 12, 13.2 mechanically operated pressure sensitive device used to determine an abnormal condition for the engine cooling system and crankcase pressure. The potential harmful conditions exist for the protective device which will cause the engine shutdown. These are the reset buttons on the vent and the test elbow and the test cock on the differential water crankcase pressure detector installation. The water pressure portion of the detector balanced with the differential pressure of the water pump output, the water pump input and against the airbox pressure to hold the oil relief valve in the last position. When the differential pressure of the cross of the water pump becomes lesser than the airbox pressure, the figure 13.3 the diaphragm causes the oil drain to flow valve open and dump the engine oil sensing device in the governor. The governor senses the low oil pressure initiates the low oil shutdown. Bleed holes are provided between the pump inlet and outlet diaphragm for the pump inlet and airbox. The diaphragms are visually indicated with the pump indicate a leak. The device provides protection against the water pump cavitation, which can result with low coolant, excessive coolant level, excessive coolant temperature, exhausted gases in the cooling system, and solvents. Overall, the cooling system failure of the water portion of the detector will trip whenever the cooling system is drained. Note: to last the water portion of the engine must be running in a cooling system vented. Alright, this shows figure 13.3 shows the low differential water pressure conditions. 1 is your water pump discharge pressure, 2 is the water pump inlet pressure, 3 is the airbox pressure, 4 is the oil from the governor, pressure 5 is your trip position, 6 is your latch position, 7 is the oil return to the crankcase, and 8 is the vent elbow, and 9 is the crankcase pressure negative. The crankcase pressure portion of the device consists of the oil relief valve comparable to one of the water portion held in the latch position until the pressure is built up, and in the crankcase, the oil relief valve is released and lube oil pressure of the engine governor is relieved. The figure 13.4 of the water pump of the governor senses of the oil pressure initiates the engine shutdown. 13.14 showed the water pump discharge pressure, water pump inlet pressure for the airbox governing the oil from the governor. 5 the last position, 6 the trip position, 7 the oil return cranes, 8 the vent valve or its vent elbow, and 9 the crankcase pressure positive. Warning: following an engine shutdown because the engine pressure detector has been activated, do not open any handhold top direct deck covers to make any inspection until the engine has stopped. They allow it to cool for at least 2 hours. Do not attempt the restart of the engine until the until the case for the trip that has been determined with the corrective the action with the pressure detector indicates the possibility of the condition within the engine, such as overheating bearing which may ignite hot oil vapor. If the explosive force of the air is allowed to enter the crankcase pressure detector cannot be reset. Do not operate the engine until the detector has been replaced, since the diaphragm backup plates may be damaged. Maintenance: the differential water with the crankcase pressure detector should be tested periodically to ensure the proper operation. Test valve in figure 13.5 with installed with the water pump outlet line in the water safety and proportion provides the means of an annual dump in water pressure on the diaphragm. In turn, provide the check of the tripping action water detector by rotating the test valve handle with the horizontal position of the discharge coolant with a small orifice hole in the valve. Should be at a steady flow because of the contaminants from the cooling of the small orifice in the valve may be plugged with reducing the shrinking of the bleed-off pressure diaphragm. In most cases, rapidly open and close the test valve a few times with dislodge the obstruction allowed with the water detector. Plunging the test valve in no way. Alright, this shows the normal position, and then this shows the test position, the figures 13.5 of the test valve portions. Okay, effect for the operation of water device with the engine running idle speed with the opening of the test valve obtaining the free flow of the coolant should trip the device in the first second try. If the device does not trip, the device should be taken off and checked on the test and panel to determine the cause of malfunction. It is recommended that the operation of the water detector be checked monthly with the test valve. The test valve handle must be returned to the vertical position, figure 13.5 before starting the engine. To test the crank pressure portion without starting with the engine, the hydrometer bulb to create the suction with the vent elbow. This strip will reset the stem as it stimulates the positive pressure being applied with the opposite side of the diaphragm. Causing the diaphragm can be damaged applying with a positive pressure through the vent tube. Exhaust air pressure for the bulb before testing. If the test is unsatisfactory, repeat the test. The detector still does not trip or play with the detector. The pressure detector can also be tested by using a hand-operated vacuum pump. Connect the vacuum pump to the T within the line between the vent elbow and the water manometer with the operator of the pump slowly until the detector trips. Reset the detector. Repeat the procedure to check with the manometer with the tripping pressure. Receive the service data for the limits. Alright, your overspeed trip. The description: overspeed mechanism provides a safety feature for the stop of the injection of the fuel into the cylinder should the engine speed become excessive. Figure 13.6 shows the mechanical overspeed trip of the mechanism. The engine speed should increase with the specified limits of the overspeed mechanism will shut down the engine. A trip shaft extending the length of each engine bank and under the camshaft to provide with a cam each of the cylinder when rotated with the contact with the spring load with the catch of the pulp mounted with each cylinder head located with the directly under the injector rocker arm and the overspeed with the tripping have in front of the engine. The trip shaft connected with the spring operated links the lever of the mechanism. Reset lever on the trip lock shaft when pulled toward the right bank. Put on the tension on a actuating spring with the tension being held by the trip ball with the engaging the notch of the trip of the lock lever. This is a normal running position in which the cam of the trip shaft held away from the rocker arm catch pawls. Figure 13.6 shows the overspeed trip shows the latch position with the camshaft and then the around the camshaft triple shaft cam injector actuating spring, the triple lock, trip lock and trip pawl camshaft counterweight, and the trip position adjusting tension screw, the trip shaft and left bank injectors, flyweight, triple shaft, right bank injectors, right bank and rocker arm catch pawl, and they show the expanded view of the triple lock and the tripper pawl. The overspeed tripling release with the main mechanism incorporated with the right bank with the camshaft counterweight with the flyweight help with the adjustment of the tension spring with the engine speed exceed with the set limit with the tension of the spring with the overcome the central figure force action with the flyweight, causing the flyweight to move outward with the contact with the triple L to allow the actuating spring with acting with the connecting link with the rotate the trip shaft. The consequently the trip shaft the cam's contact with its array with the injector rocker arm pause with the preventing the full injection of the injector rocker arm roller contact with the cam with the preventing the fuel injection with the stop of the engine. Upon resetting with the counterclockwise movement of the reset with the lever of the figures 13.7 the trip shaft cam release for the injector rocker arm the catch of the rotation of the camshaft with the starting engine lift with the rocker arm slightly allowing catch ball to resume unlatched position, releasing the injector rocker arm for a normal operation. Alright, figure 13.7 shows the reset lever position latched and tripped. Maintenance of the drain sleeve removed with lubricating the oil from the overspeed train. Trip housing drained into the top of the accessory drive housing through the two removable cast aluminum drive sleeve. Figure 13.8. Each sleeve has two rubber O-rings. If the oil leakage is detected between the housing of the sleeve, this should be removed and the oil ring seals replaces fouls. Alright, figure 13.8 shows the overspeed tripping housing drain sleeves. You see the drain sleeve and the retainer, the drain sleeve and the seals. Alright, move the overspeed tripping housing over the bar over the engine until the counterweights are positioned on the top of the engine. Remove the bolt and steel retainer strip, the figure 13.8 with a holding sleeve. Using a suitable pry bar, insert the under sleeve with a handle. Carefully remove the slip and the sleeve of the housing. Remove the seal from the cleaning sleeves. Install the seal marked in the red dot upper groove with the sleeve with the unmarked and seal with the lower groove. Apply the film of the oil seals. Oil on the sleeve until the sleeve of the bolt and the retainer strap. Adjusting mechanical overspeed strip. The adjusting overspeed trip with the shutdown engine remove the cover of the right side of the overspeed trip housing. The turn adjusting figure 13.9 to decrease the spring tension required to increase the engine speed of the overspeed trip to increase the spring tension. Figure there in 13.9 show the overspeed tripping adjustment, adjusting nut and the lock nut. After the adjusting nut has been moved, the lock nut must be tightened when the engine runs the test speed at the bridge. The trip operates the speed right of the engine from the idle trip. This should be made between 20 and 30 seconds. Several adjusting that may be required before the final setting of the tripping set is reached. Hot oil shutdown. Description: the hot oil shutdown device in 13.10 consists of the thermostatic valve associated with the piping. Figure 13.10 shows the hot oil shutdown installation, oil pressure relief line, and the hot oil thermostatic valve. The valve is located in the discharge elbow with the main loop oil pump piping. The valve is connected with the oil pressure line between the Differential water crankcase pressure detected for the governor, also with the drain line piping the valve of the governor driving housing. When the oil temperature reaches 255 to 260 degrees Fahrenheit, the thermostatic valve will open and the pressure of oil will also pass through the valve and drain into the governor driving housing. The governor senses the resultant low oil pressure and initiate the engine shutdown. Maintenance. The thermostatic valve should be removed and tested at intervals specified and applicable to the scheduled maintenance program. Or surface data protection devices. New limits are the width and the new parts of the manufacturer drawing tonnage, minimum and maximum tonnage measured to provide with the surface immediate time to rebuild any time with unscheduled measure. And this is performed the surface limited should not exceed, but any components within them may be used with the assurance of the performed satisfactory next schedule overhaul. Differential water crankcase pressure detector, water proportion tripping pressure with no pressure for the water chamber to increase the air block pressure from 0 to 2 tripping measurement pressure new minimum use minimum crankcase portion tripping pressure new and minimum meaning the new or rebuilt devices less than 3 months in service. The overspeed trip, the clearance trip, the lash for the flywheel, minimum trip resetting, equipment listing, hydrometer bulb, the testing panel, and vacuum pump. That completes section 8, 13 protected devices.